So like Alexi said, today is going to be, at least for the next 40 minutes, will be mostly about deploying models. I'm going to try to sneak in a little Spark in there, but we'll also talk about TensorFlow as well too. Yeah, as Alexi said, I have this combined Spark and TensorFlow meetup. And actually, so yeah, today's talk is going to be all Jupyter Notebook. And it's going to be demos. Where the demos break, I'm just going to kind of fake through it and show you guys so the results that were generated right before this talk, if anything happens. Yeah, so here we are today. Let's see, who am I? Chris Fregly. I'm pretty famous for this emoji. At least I think I'm famous in my head. For one of my friends got me this emoji that looks just like me. Am I wearing? Oh, yeah, no, I'm wearing my, I'm bringing taxi back with this hat here. This is, yes, I bought this off a taxi driver down in San Jose, like 6 years ago. I was all drunk and gave him $50, and it was like the happiest day of his life, and I woke up with this hat and $50 less in my pocket, so. But yeah, the emoji is the Cubs from Chicago, and we won now, we're the world champions, or the World Series champions, but it's now, I'm scared to not wear the hat because maybe something, some other, I don't know. Yeah, there's a lot of stuff here. Okay, so research scientist, Pipeline IO. I haven't even changed my slides. I go back and forth between Pipeline AI and Pipeline IO depending on who I'm talking to. I've got this thing called the Pancake Stack. It's kind of funny. The thing to remember from this talk, yes, I should mention that the last time I gave this talk, it was 4 hours. And that was like a couple Tuesdays ago, so we're going to do 4 hours in 40 minutes. So there's a lot more here. If you go to Pipeline IO, you'll see all the code off of GitHub. Everything's 100% open source. I don't make money. The investors are asking why I don't make money. I just don't call them back. That's my plan. So Pancake, yeah, there's a lot going on. There's Presto, and yeah, there were a lot of A's in Pancake Stack, so I started getting a little creative. I got in trouble from the Apache folks for not putting the word Apache in front of everything, and I had to remind them that it would just be the PA stock, stock, kind of thing. It would just be a bunch of A's if it was all Apache, Apache, Apache. So don't photo this and tweet it too far, because then they start coming after my ass. Working on high performance TensorFlow in production. That'll be coming out later. The end of this year, it's going to be the end of this month. There's some online training. Yeah, you can click through. I think the way that the O'Reilly people do it now for the online training is that you have to sign up for Safari. So they're kind of going like the Netflix route, the recurring subscription seems to be a big thing around here in the Bay Area, right? So VCs like these recurring things versus just a one-off. So I think if you're a Safari member, you can get to it. We're going to be covering a lot of optimizations, going into way more detail than we do here. Once you've trained your TensorFlow model, there's things that you can do to the TensorFlow model to make it score faster, right? And like smaller devices, things like that. So I'll mention some of them here and in the context of deploying. Yeah, so again, here's the meetup. Yeah, there's Chester. There was Chester. Yeah, right there, Chester. Yeah, between me, like Alexi and Chester, 90 meetups last year for Spark and Spark-related things. Here's the GitHub repo, Docker Hub, all the slides here. Worked for Netflix, worked for Databricks, did a brief stint. One of the early members of the IBM Spark Tech Center. We were trying to grow that thing out pretty quickly. It was a pretty fun challenge, trying to wear shorts in meetings where everyone had khakis and not just khakis, but pleated khakis, like from the 80s, like Old Navy type khakis. So yeah, I just bring my the cargo pants, and yeah, so we changed that culture a little bit there. That was fun. Yeah, actually, IBM Spark Tech Center now has, I think, 4 committers, or yeah, maybe even 5 Spark committers in that group, which was pretty amazing, seeing as we had 0 when we started. So I'm a Spark contributor, not a committer. All right, some of the tools that we're going to be working with today are Docker, Kubernetes. Anyone here use Kubernetes in production? Anyone use Mesos in production? They're used for slightly different things at this point, but okay. How about, I guess Yarn, right? It's like everyone Yarn. No one Yarn. All right, good crowd. So this is Weave Scope. This is a fun little tool on top of Kubernetes. This is one of the open source products by this company, Weaveworks. So let me zoom in a little bit just so I don't forget. And I learned this trick the other day, so it doesn't take up half of the screen. So I'll actually show this live here in a sec, but this is the training cluster. Yeah. Oh, actually, this is both a training cluster and a prediction cluster. Here's where you're going to have your TensorFlow, your High Metastore, your Redis, got Kafka, things like that. So shows all the moving parts. So these are all Dockerized, right? This is all within that same GitHub repo. These are all pushed out to Docker Hub. You can pull these down. You can essentially, with just a couple clicks, you can create this whole environment using Kubernetes. So you can do it locally now. There's something called Minikube, right? That really changes the game. Similar to how there's Docker for Mac and Docker for Windows, now you can actually run an entire Kubernetes cluster on your local laptop. It's not always successful just because of the available RAM and things like that, but it's fun to try anyway. We'll be using Jupyter. We probably will not leave Jupyter much during this because we can do everything from within here. Who here uses Airflow? Do you? Yeah, right, we were just talking about that. Who knows Jenkins? Yeah, anyone heard of Jenkins, right? Where you build code. The kind of hot new thing is that you continuously build code, right? You have your little source Java directory, and you make changes throughout the day, every 10 minutes, every hour. That code, you want to push it out. So when I first, so think of continuous model deployments, right? So think of it similar to how you would do continuous code deployments. I started setting up Jenkins when I first set out to tackle this particular use case, the continuous deployment of models. I realized I had to learn another goofy, groovy DSL that I guess was the old workflow DSL that they renamed to pipeline DSL. It was just a lot of heavyweight stuff. I've used Jenkins all the time, pretty much. The past 4 or 5 jobs, we always use Jenkins or Hudson or some form of that. I was trying to find something different, something a little bit more Python-y. I have a Java background, but most of the people I talk to have data science backgrounds, have Python backgrounds. So I was trying to kind of fit their world and not force people to learn Java and the JVM and some of these things. So yeah, these Airflow operators, they're called. You can set up these DAGs. So similar to a TensorFlow DAG, right, where you have operations, or your Spark DAG, where you have a map and a filter and joins and things like that. Think of this sort of like a production workflow DAG, right? So here's a case. Let me see, I think I could show one here. So here's one. So picture the ability to trigger these DAGs, right? That's the term that Airflow uses. And a valid trigger would be committing something into GitHub. So imagine training a model within the notebook, which we'll do here in a sec, and then commit that. That's going to then do a callback, right? It's a post-commit callback, right? Webhook back into Airflow, and there's an Airflow server running out there, and it actually triggers this particular thing, passes this GitHub hash, right? The commit hash, builds a new Docker image with that model that you built, that TensorFlow model or Spark model that you built. And then does its thing, pushes it out to whatever Docker Hub type repo that you have for your Docker for your Docker images, and then in parallel can actually update both Amazon. If you're running in Google, you can update that as well. I had Azure running for a little bit, and then I forgot my Hotmail password, and I don't know what to do anymore. I'm just kind of locked out, still paying money for something that I can't seem to delete. So. Let's see, back to here. Yeah, so Airflow has become kind of a critical piece now. I just went to a meetup the other day at Galvanize, I think it was last week, 2 weeks ago. It was one of the Airbnb people speaking about Airflow. He's actually on the Airflow team, he's an Airflow committer. Sort of talking about the history of it, the problems that they were having, the other tools that they had, things like Jenkins, that kind of stuff. And one thing he showed me was, so one thing that's been on like my mind recently is not just deploying these models, but actually A/B testing them, right? Like doing multi-arm bandit testing where you kind of shift traffic towards the winning person so that you're not completely screwing all the other right, like bad experiments, right? The people using that have been slotted into those bad experiments for the duration, for the 3 weeks or 4 weeks of this right, like particular test. And he popped up, there was this like slick HTML UI that was tied to Airflow here, and it actually right, like let you set the prior distributions on those different tests, right, like A, B, C, D, E, F tests, and then give it the duration for the test itself. And that would actually generate right, like the YAML that's used, this is actually Python based, right? So each of these is an actual Python, I think I can get to it from here. Yeah, these operators are just Python code. So if I back up, I should be able to drill in and go to code. So this is actually one, so right, like this is the example where I've created a new TensorFlow model using some new hyperparameters, trying out right, like a new architecture, which is a form of hyperparameter. And I then push it, and from this creates a Canary. Right, so just to kind of show that visual version that I had showed here, here's the actual code version of it. So, right, like the interesting thing will be these two happening in parallel, which is the very last step. So, right now, I just kind of, because I'm like still getting, I'm still trying to learn Airflow and some of these libraries. Oh yeah, so just picture Airflow just like it's a Python library, right? And yeah, you can extend these things. Yes, I'm using, right, like for here, bash operators, which is just kind of a generic, right, like execute this, right, like bash command. So at the very end here, like you'll see, so once the image has been pushed to Docker Hub, then right, like these two things then trigger off of that, which is update Amazon and then update GCP. So right, like that's where you actually get this parallelism. You would use Airflow in conjunction with Celery. Yes, I didn't know any of these terms before because right, like I've always been kind of a Java guy, but yeah, apparently everyone knows Celery. There's this tool on top of Celery called Flower, right, that actually lets you inspect the tasks. So picture Celery is kind of, you're just submitting tasks and, right, so as there's like task workers available, it'll just start gobbling them up and then doing them. Yeah, so you can scale up, yeah, and then Flower, yeah, like, it's kind of a funny name on top. Yeah, so that's how you would actually build these things sort of end to end. Okay. Oh, and then if there's failures and errors and things like that, of course, you can notify yourself. Or have it send an email to PagerDuty. Right, like one thing to mention, I mentioned the like GitHub dependency, right? Like never, ever, ever depend on, right, like GitHub for like anything, right? That's, so at like Netflix, for example, they run their own stash service that's like highly available and, right, like supports the Git API and all that, but they have control over the availability. This is such a critical part. Oh, yes, I didn't finish my thought back here. It was, yeah, so this particular run actually goes through, builds a Canary from that newly committed model, right, like builds the Canary. And so that term Canary, think of it just like Canary code, right, that goes out, that whole like Canary in a coal mine where you stick something out, right, like into the coal mine, see if it lives. Yeah, if it fails, then, right, like tear it down, don't go that direction. So yeah, this particular flow would create that one Canary that sits alongside the other 1,000 model servers, right? So now you have 1,001 that are all taking traffic, right? So there's one load balancer coming in that's spraying it out. You then have a dashboard where you can actually compare, right? Like not just like system stats like load and right, like heap and like things like that, but you can also look at like predictive performance as well too. You can actually compare predictive performance. So for the same inputs, right? Like the old model gave you this, and now this new model gives you this, and if they're wildly out of sync, if one just right, like keeps saying, no, this is not spam, but right, like the real model or the current model is, then right, like you would know what to do. And now one thing for these deep neural networks, one of the hyperparameters, of course, is how deep like your network is, right? So one thing to keep in mind is that you may see latencies go up, right? So if you're a data scientist person sitting down building a new model and you're like, well, wait a minute, I'm just going to make this thing 50 layers deep, right? Yeah, so that has to be better, of course. And so you go to deploy that model, and now, right, like the average latency, 90th like percentile latency goes up to, right, like 50 milliseconds, whereas you have kind of a, right, like a 10 millisecond limit. And so you would actually see 50 milliseconds versus 10 milliseconds, right? That's a system metric. This is actually a dashboard that's shown to the data scientist through this process, right? So I think someone, so there was a talk earlier today about kind of keeping, right, like data scientists, right, like don't have to worry about infrastructure and, right, like things like that. Like, so they certainly shouldn't have to, right, like know the details, but from, right, like our standpoint, right, like we want to show them these dashboards, right? Like give data scientists data, not just about their training, like results and all that, but like how is this actually doing in production on live data? Okay, so mentioned the Canary lease. Think of continuous deployment more than just code, right, like, but also your trained models. I'm a big fan of dashboards. This is something I learned and was kind of beaten into me at Netflix was if you are pushing out code that you don't have insight into, right, like new code that you pushed out, new models that you pushed out, and you can't, right, like defend what's going on or if something's happening, right, then you basically already lost. You should just take it out and then re-instrument it and then put it back out. Yeah, so something that was tough under, at the time we were under like 2-week iterations, and of course metrics is always the last thing, things like error counts and all that. And sometimes you would instrument specifically for that use case, and then you would just kind of put it to do to take out the instrumentation later, and of course that never happened, right? So like you really have to be disciplined. But here's one example. This is like one of my favorites. So this particular concept, this is directly related to serving like models, right? So this concept of a circuit breaker. So Netflix has this open source library called Hystrix. This is kind of how it looks with all these kind of detailed out. It's very, very visual. I can show you guys. This is across both Amazon and Google. Let me actually fire this up. I think I'm pointing at Google right now. Boop, boop. Yeah, so what you'll see again, right, like this is metrics, this is data for the data scientist to see what's going on out there. He doesn't necessarily have to right, like respond to things that are going on, but if you are doing Canary analysis, right, like you would want to compare and see what's going on, but those PagerDuty alerts, right, they should like typically go to the ops person. I wouldn't like necessarily expect that like data scientist person can actually fix the problem. But they can definitely fix things that they know, right, like latencies and things like that. So this is a super small load test, and actually this is being limited by my laptop because I'm running JMeter locally here. I've got JMeter in the cloud, but if we have time, we can load it up. And I could switch over and show Amazon as well, too. So these are, right, like deployed services here. So I'm kind of showing you guys the fun metrics part, and then we'll back into how we got here. So we should see the Amazon stuff light up. And we can actually compare if this UI was a little bit tighter, like we might even be able to, oh, yes, I'm only running one at a time. But at one point, I was getting, for the same price per prediction, right, this is one metric you can pay attention to. So the same size of instance, I think it's the N1, or it's the N1 high mem 8 or something on the Google side, which is equivalent to like an R32XL. So it's basically 8 cores, about 50 to 60 gigs of RAM. At one point, I was seeing Google twice as cheap or half the cost per, right, like per prediction. So the same, right, like load was going in, it was able to serve it up faster. And I haven't really looked into any of the like hardware specs between those two or which ones I was getting at that time, but right, like something to like keep an eye on. And then think of the ability to sort of auto shift, right? Like we know about auto scaling and scaling up throughout the day, scaling down throughout the day. Now, right, like you can cross clouds, and at any given point in time, say in the morning, right, like we just lost all of our spot instances, which are cheaper instances within Amazon, and now maybe Google instances are cheaper, so we could slowly shift traffic over, right? Like based on this, right, like price per like prediction. Yeah, also to the obvious, like high availability, right? It's now multiple clouds that are able to serve the same load. So if Amazon goes down, right? Yeah, so God forbid S3 goes down, right? Like when's the last time that happened? We can definitely shift over. All right, so I had mentioned before, in these tests, I've purposely isolated out the prediction cluster. Now, prediction cluster is, so I'm using Netflix-based microservices, right? So that has a lot of the circuit breaker stuff built in, that has all these metrics built in. I'm actually pushing also like along the lines of metrics here. I've got Prometheus going. Prometheus is very, very, very Google Kubernetes friendly, but it's really totally generic here. So there's kind of the generic like Prometheus, then of course Grafana on top, right? So all of this is there for you guys to play around. I think I have, unless I killed it, might have killed the dashboard. Airflow. Yes, I killed it right before coming. Yeah, so you can like build these dials and things like that are in here, these like gauges, right? That's one of the types of metrics. Right, like gauge would be like your speedometer on your car kind of thing. And that will come in handy in a sec here. Let me show. Yeah, so I purposely split out so that the prediction cluster isn't competing with the Spark jobs, of course, and TensorFlow builds and all that kind of stuff. So if I show you guys live the Kubernetes cluster here on Amazon, we should see, I could filter by host. Sometimes this thing likes to bounce off the pods. All right, there's pods. $5 minutes? Oh my God. Oh, right, because of like Q&A? Is that the, gotcha, okay. Yeah, so this is your like prediction cluster here. So yeah, I haven't gotten to it yet, but there's like different ways to deploy things. There's just generic kind of key value, so that's this guy, key value. There's TensorFlow, right, which has the TensorFlow runtime. It's got tools to like optimize the actual graph afterward. I've been using PMML with my Spark ML models. It's pretty handy. It seems to work for most of the just like vanilla Spark ML. I've got a generic Python thing, so you can actually deploy like code out there, your scikit-learn code, that kind of thing, and it's going to execute that. And this is all wrapped in these Netflix services, right? So if your Python like scikit-learn stuff starts to get a little wonky, like it'll notify, there'll be circuits broken. You can compare Python, or yeah, you can like compare scikit-learn to your like Spark ML models to your like TensorFlow models, all within the same framework here. So, all right, so let me keep going. TensorFlow serving is pretty much the heart of serving models with TensorFlow. They're like a little bit weird about upgrading the actual version, so you pretty much always want to be on master. That gets you in trouble. Also, for like demos and things like that, it's a bit scary. They're not as like diligent as the actual TensorFlow core team, but so yeah, here's some like model deployments I want you guys to think about, and right, like just like generic key value pairs. So just think of right, like offline generating recommendations, so right, this is something Netflix would do, right? For each user ID, just have the top, right, like the top 100 like movies that this person, when they like go to log in, that should be served up. So it would literally be key of their user ID, and then value is this array of like video IDs, 3 minutes, all right. And so TensorFlow serving, funny enough, right, like you always think of TensorFlow as kind of a neural network system. There's actually this right, like generic right, like concept here, hash map. And yeah, so they realized we're right, like not just serving up neural net models here, but we can also serve up key value pairs. So they must have had that use case pop up in so much that, yeah, PMML, it's a 4-letter word here in the Bay Area, right? Like we all know this. I see it used, I've seen it customized, I've seen it right, like all different ways. A lot of people are using it. I was just doing a lot of like performance tests with it and actually ended up being pretty handy. There's a couple other ways I want you to think about deploying code, right? You can actually take PMML or take some, right, like take some sort of source like SparkML and actually generate, right, like native Java code, native C code. The cool thing about generating native Java code is that this can now be part of the just-in-time, right, like the whole JIT compiling thing that right, like these JVMs do, right? It can do the inlining and all that. And of course, TensorFlow model exporting. This is kind of a handy tool. Now, this tool is called, well, yeah, actually FreezeGraph. So, right, like just real quick on TensorFlow, when you build your model, what you end up with is a directory, right? So it's very rare that you get just like a .model file or whatever. So one part of that directory, one file within that directory is a static graph. So that's the DAG, right? That's all your operations. That's your matrix multiplies. That's all that stuff. There's a second file for the trained weights themselves. And these are called checkpoints. The new version of TensorFlow 1.0 makes this a little bit cleaner, changes the API like a tiny bit, but it's a little bit more understandable. Cool. And so what you have to do when you actually go to serve these models, right? Like you have to call something called FreezeGraph, or that's kind of logically what it's called. It's physically the name of this Python script here. And it's, so what would be a variable inside of your graph, for the for the operands of the matrix multiply operator, the script goes through and slams in the current trained weight and puts right, like from that checkpoint file into the actual variables. And so they become constants. And so the reason that these checkpoint files kind of live separate is that you could always pick up from that like current checkpoint file and then continue to train, right? So those would be the starting values, and then just keep training. You could potentially overfit. Yeah, a couple things to think. Mutable. So I mentioned before about building a new Docker image, one Docker image per model, right? So it's a nice way to kind of get traceability all the way from the commit hash back, and right, like you would use that same commit hash version, for example, on your Docker image, so that you always know what's out there. A couple other things. This graph transform tool is sort of the replacement for some of these smaller scripts that, or right, these kind of early scripts to optimize. So things like, let's see if this is taking a little bit to come up. But think about like during the training process, right? You're doing things like dropout, right? So these are very specific to the actual training process. When you go to score, right, for like the inference side, you want these operations to not be there. And yeah, so dropout's slightly different in that so typically you, on the serving side, you would overcompensate for what was dropped out. Yeah, but actually TensorFlow knows this, and so right, like during training, it's doing tricks in there to actually, right, so that nothing has to be done, so that you can cleanly just remove those like dropout nodes. But yeah, things like summaries, if you're writing out like summaries of your variables during the training process, those are not needed during the inference. So yeah, check out Graph Transform tool. Pete Worden was picked up by Google to do sort of small device and 8-bit quantization, things like that. You train at full 32-bit like precision, and then you actually, when you're done training, you would just lop off and go back to an 8-bit int. And because this is all kind of fuzzy anyway, right, now on the inference side, it's not going to be the exact like predictions that you would have gotten with the full 32-bit, but it's much, much smaller. And on GPUs, right, like, yeah, this is actually like quite a bit faster because you can pack them in, make them more dense. One really cool thing to keep in mind is it a hard stop at 140? Is that? Oh, the next speaker starts. Okay, so this concept of so if you picture that top request, so like for whatever reason, this model needs to do this matrix times vector for, right, like whatever, it's trying to classify something, it just wants that result. So that's one request coming from one device in, right, like Japan somewhere. That next one, right, like the server happens to get both of these requests at the same time to do like matrix times vector. And like the sort of naive way to do it, or the sort of low throughput way to do it, is to just do these separately, right? So pass them both in, and picture GPO, right? Like on a GPU, where it has to then channel through PCIe Express or like whatever. So now what you could actually do is wait, 5 millisecond, 10 millisecond. So here you're like trading off latency for throughput. And so let's say this is the 2 requests I picked up within some window of 5 milliseconds or whatever. I'm going to pass both of those in, do a little padding here, because I know the offsets on the way back. So this 1, 2, 3, 4, just to make it clear, is just this guy and this guy. And these 2 are kind of put right like edge to edge right there. And so this is the exact same results based on these offsets. And now you can actually just return to each caller that specific. So right, like with one big matrix multiply, yeah, huge improvement for throughput. If you have low throughput, it's probably not worth it because you do have that 5 or 10 millisecond latency. All right, so demos. I have a couple minutes here. Let me just kind of yeah, this is like a little bit janky, like mainly because I haven't built any real tooling into Rally Jupyter Notebook. I just got to sit down and figure out Tornado, I guess. But think of this happening behind the scenes where we're actually so we would build a model. It would end up in this directory 0027. That's the new version. We would commit it. We would push it. That would start the new airflow. You could actually watch airflow from within here. You can actually, if you do Shift-Enter, you should be able to see it. Here's the Kubernetes cluster, and yeah, that's pretty much all I got. That'll fit in. Yeah, this is much less than 4 hours. Any questions? No time for questions. All right. Yeah, those are my favorite questions. Thank you.